Good day everyone. Today we will discuss about the sampling distribution of the sample mean, the normal distribution. First, let's have a short recap about the properties of the normal distributions. It is a continuous random variable, has an infinite number of possible values that can be represented by an interval on the number line. In this number line, the time spent studying can be any number between 0 and 24. The probability distribution of a continuous random variable is called a continuous probability distribution. The most important probability distribution in statistics is the normal distribution. A normal distribution is a continuous probability distribution for a random variable x. The graph of a normal distribution is called the normal curve. Properties of normal distribution. The mean, the median, and the mode are equal. The normal curve is bell-shaped and symmetric about the mean. The total area under the curve is equal to 1. The normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. The points at which the curve changes from curving upwards to curving downwards are called the inflection points or the points of inflection. So now, for large samples, the central limit theorem tells us that sampling distribution of sample mean is approximately normal. If population is normally distributed, then z is equal to sample mean or x bar minus mu over sigma divided by the square root of n at follows a standard normal distribution of sigma is none. And t is equal to sample mean or x bar minus mu over s divided by the square root of n follows a t distribution with n minus 1 degrees of freedom if the sigma is unknown. The sampling distribution of x. Because of E of x is equal to mu or mean, the sampling distribution of t centers at 0. Because of sigma or the standard deviation, a constant, it was replaced by s, a random variable. The sampling distribution of t shows more variability than the sampling distribution of z. The sampling distribution of t is known as t distribution. It is derived by William Gossett in early 20th century, and later on this distribution came to known as student's distribution. The t probability density function. The t probability density function is symmetric about 0 and has a wider tails or more spread out than the normal standard distribution. The shape of the distribution of t depends on the degrees of freedom. As the degrees of freedom increases, the t distribution approaches the z distribution and t sub alpha is equal to the t value that cuts off an area alpha in the right tail of the t distribution. Only upper tail values are given in the table because of the symmetry of the density function. Because the t distribution approaches the standard normal distribution as n gets larger, note that the t sub alpha is approximately equal to z sub alpha for larger n. Example: concrete filled tube columns are used as a structural support due to their excellent seismic resistant properties. A structural engineer conducted an experiment and recorded failure strengths of 12 samples, and the standard deviation of measurement was 989 kilonewtons, symbol of force. It is known that the failure strengths are normally distributed with the mean of 3000 kilonewtons for this type of column. So what is the likelihood of the mean failure strength of 12 samples being lower than first A 2000 kilonewtons and then B 2500 kilonewtons? So using the formula, T is equal to sample mean minus mu over S divided by the number of N. We can conclude that the probability of sample mean less than 2000 is equal to the probability of T less than 2000 minus mu over S divided by square root of N. Substituting the value, P, probability of P T less than 2000 minus 3000 over 989 divided by the square root of 12, then will result in an answer P, probability of T less than negative 3.5. Using the T table, we can see that for the 11 degrees of freedom, the 3.50 is greater than 3.106. 106 equals T sub 0.005 degrees. Therefore, we can conclude that the P probability of P T is less than negative 3.50 and less than 60.005. Using the calculator or other computer software, we can get the exact required probability as P, probability of P T less than negative 3.50 equals 0.0025. So in solution B, let's say that the sample mean is less than 2500. So probability of P T is less than 2500 minus mu over S divided by number of N equals P of T less than 2500 minus 3000 over 989 divided by the square root of 12 equals P of T less than negative 1.75. Using the T table, we can see that for 11 degrees of freedom, the T sub 0.10 is equal to 1.363 less than 1.75 less than 1.796 is equal to T sub 0.05 degrees. Therefore, we can conclude that the 0.05 is less than the probability of P of T less than negative 1.75 is less than 0.10. In fact, 1.75 is very close to 1.796 equals T sub 0.05, which tells us that P of T less than negative 1.75 is just slightly more than 0.05. Using the calculator or others computer software, we can get the exact required probability as P of T less than negative 1.75 is equal to 0.74. So that's all. Thank you. I hope that you enjoyed and learned so far in this discussion.